charge, maybe just one. This post suggests there is not positive and negative charge, but one charge with two wave patterns that act like two charges. This, if correct, will resolve some major problems in physics. See list at end. The first rule of electric charge is electrons attract positrons and electrons repel other electrons. Positive is attracted to negative and like charges repel each other. This post suggests that is wrong, and there is only one charge. That single charge is attracted or repelled to another charge, depending on how the two identical waves are spaced apart. Charge depends on whether two of the same waves are spaced apart to make a constructive or make destructive interference. Two waves in constructive interference combine into an energy zone. Two waves in destructive interference annihilate into energy that moves away and leaves an empty, dark zone. There is virtually no probability of finding waves in these dark zones. See top of drawing. It shows two identical waves on the left. Then on the right it shows one wave moved a half wavelength over. This makes two mirror waves. The rule is two same waves combine in constructive interferences, but two mirror waves annihilate in destructive interference. Lots to read online about constructive and destructive interference in sound, light, two-slit experiments, etc. So my suggestion is there are not electrons and positrons, not electrons and anti-electrons, not positive and negative charge, but wave and mirror wave. Wave and wave act like two same charges. Wave and mirror wave act like opposite charges. With constructive interference, the two identical waves combine to make a wave with twice the amplitude. With destructive interference, the two mirror waves annihilate each other in destructive interference that creates a release of energy. This makes a dark, empty zone. My suggestion is that charge in an atom is caused by waves in two adjoining energy zones that are in destructive interference. Where the two waves meet is a dark, empty zone of wave annihilation. This pattern goes from the nucleus out. Each wave zone is attracted to its neighbor on each side, with destructive interference acting like opposite charge. These wave zones alternate with empty dark zones where they meet. For an image, imagine a solar system. The planets are the wave zones of energy. They are separated by dark zones of empty space, though I admit this, like the Bohr model, is a gross simplification. For another image, imagine stepping stones across a creek. Therefore, the atom, its nucleus, and its assortment of surrounding waves are each waves of energy separated by dark empty zones. See drawing on the bottom. Why would these wave zones be in destructive interference if they were the same wave? Because each standing wave is in an orbit that is different. Each standing wave is in an orbit that shifted the wave, like the top right of the drawing. Each orbit has a different orbital path with a different distance. This means each orbit shifts the waves so they are not the same as its neighbors, but instead mirror waves. Waves that don't fit this pattern won't be in the atom. Note also that there is a dark zone between the nucleus of the atom and the first electron shell. This is a simplification because I think the nucleus is itself made up of sets of particle zones in destructive interference, but separated by empty dark zones. What about a case where both waves are identical? Will they repel each other like electrons and electrons do? They should, but don't always. They often form constructive interference. This constructive interference of two same waves acts like two electrons in a shell. Both electrons are standing waves, though they have the same charge and are in the same orbital. They coexist if they have opposite spin. Notice that electrons in the two-slit experiment combine to make the stronger wave zones with constructive interference and destroy each other in the dark empty zones with destructive interference. But electrons are supposed to repel each other. They don't in the two-slit experiment. Yet clearly we also know that in atoms, electrons with negative charge are attracted to protons in the nucleus with positive charge. How could all these facts fit together? Consider an atom is similar to the two-slit experiment pattern. There are wave zones of energy. They alternate with dark zones of no energy. Throughout the atom, different bands of wave zones alternate with dark no-wave zones. The bottom of my illustration shows a simplified atom model. Real atoms are much more complicated, but the concept is the same. Start at the center and move out. So in summary, how can there be just one charge? Because two of the same waves can act as either constructive interference and combine, or as destructive interference and annihilate to make a dark, empty zone between them. This post may resolve some of the following physics problems. Where is the missing antimatter? It's in the atoms. What is charge? Wave and its mirror wave in either constructive or destructive interference. Why there are dark zones in atoms and in the two-slit experiment. During a quantum jump, the charged wave or particle crosses a destructive interference zone. There is annihilation and photons are created or taken in. This may connect with how the charged wave or particle crosses these dark zones.